Hi, welcome to our FlockForce milestone presentation. So we are FlockForce. We're doing a compute shader Boyd simulation using Godot engine. And so I'll just first show the program that we got running this week. So this is a CPU-based Boyd simulation. So we're doing all the rendering, or we're doing all the calculation of velocities on the CPU. And it works. As you can see, they do flock, although they do bug, but they flock. And we can get about 100 of these voids before the performance starts to suffer a lot. Also because it's like n squared algorithm or whatever, but yeah, it works and we can use it as a benchmark. So with that, I think we'll start discussing the slides.
So in week one, we implemented a version of a void simulation algorithm in Godot. The simulation is written using GDS script. It's basically like a native language for Godot, like the game engine. Um, the algorithm currently runs on the CPU and uses no acceleration data structures to speed up the search for neighbors.
So moving on to week two. For week two, first thing that we had to do was figure out how we were going to use compute shaders, how we could interface with them using Godot and the Godot game engine, and also what we were going to have access to in terms of sharing information in between the CPU and the GPU. So the first thing that we did was follow a tutorial that was given in the Godot documentation, just to see sort of how do you set things up, how do you link a compute shader to like a CPU work cycle and start giving it tasks. And then with that information, we wrote our first draft of essentially the same algorithm as we used in our CPU simulation. We wrote that in a GLSL shader, and now have to do a little more work to get that working. Um, and then some more work on top of that to optimize it and get it to run efficiently.
Yeah, so that's what we've done up to this point. Next steps are finishing up the compute shaders for GPU-based rendering, along with implementation of the Boyd's algorithm and optimizing it. So our objective would be to optimize the Boyd simulation performance and number of Boyds so we can simulate and render it. Currently, our plan for future weeks include experiment with the GPU particle 3D node and other methods of GPU-based rendering for our void simulation, and implement a better neighborhood searching algorithm that is better than just searching through all the voids that we currently have spawned.
Thank you.